Assalamu alaikum students. Right now in this video we are going to solve this example that we have to find the iterated kernel, or you can say iterated function, for specified values of a and b. Lower limit of integration is a and the upper limit of integration is b. Sometimes they can also give this to you in this way, like 0 is less or equals to x is less or equals to pi, or 0 is less or equals to t is less or equals to pi. So they means the same. The lower limit is the a and the upper limit pi is your b. You have to find the iterated kernels. It means you have to find k1, k2, k3 and so on. And then you have to find the general kn or km. You know that by the iterated kernel definition, k1 of xt is k of xt, and it's the same as given in your question. Now, the nth kernel kn of xt can be written as integration from 0 to pi, x to z and z to t. So finally it's xt. And which variable you have introduced? Z. So the integration is with respect to z, dz. This is k1, so this will be kn minus 1. So this is the nth iterated kernel. You already have the value of k1. You need the value of k2. So in place of n, just put the value n equals to 2 in this main equation. Here 2 minus 1 will give you k1. So just you need the value of k1 z of t. Right now you have the value of x and t. You need z and t. So in place of x, just replace the z. In place of x, you are going to replace the z. So it will be ez cos of t. And you need the value of kxz. Kxz. So here t is replaced with z. So ex cos of z. You need to be very careful while using these values. Now you know that integration is with respect to z. So just keep the variable z inside the integral and move all other variables outside the integral. Now we are going to integrate it. You can integrate it by integration by parts method. But you know that integration by parts of exponential and trigonometric is very lengthy. You can use its direct formula as well. You can memorize this formula as well. But if you don't want to memorize, you can use here the integration by parts. The formula is integration eax cos bx dx is equals to eax over a square plus b square, a cos bx plus b sin bx. A is right now here 1. Here this is a. And the coefficient of this z is your b. B is 1. This a and b is not these one. Right now a and b are, a is the coefficient of x and b is the coefficient of x here in trigonometric function. Now replace the values here. E raised to power ax, e raised to power 1z, a square 1 square plus 1 square, cos 1z plus sin 1z. And limits of integration are from 0 to pi. First of all, I will put here in place of z the upper limit pi. Then I will write the sign minus. And then in place of z, I will put this lower limit 0. And then simplify. After simplification, I will get this answer. I got right now k2 of xt. Now I need k3 of xt. So you have to put n equals to 3 in your nth iterated kernel. When I plug in n as 3, I will get k3 of xt equal integration from 0 to pi k of xz, k2 of zt dz. Now I need these values. K of xz, it's the same, k of xz, ex cos of z. I need k2 of zt. This is k2 of xt. I need k2 of zt. So in place of x, I am going to plug in here z. So I got this value. Now move all the variables outside that are not depending on z. This is 2, not z. This is 2. You know that integration is with respect to z. So move the constants out and ex and cos of t outside. Now again you got the same integral ez cos of z. So I have used its value ez cos of z. I have used its final value here, and after using its value you can see that we got this answer -1 square 1 plus e raised to power pi over 2 whole square ex cos of t. Now if you observe, we got some kind of pattern. You can see for k2 I got -1 raised to power 1 and this raised to power 1 ex cos of t. For k3 I got -1 square 1 plus e pi over 2 whole square ex cos of t. You have to do these iteration unless and until you get some pattern. So according to that pattern, you can see if you have 3, it's 2 and 2. Ex cos of t is coming in every term. So what it means, iterated kernel will be kn of xt. This 2 is 1 less than 3. So -1 raised to power this n minus 1. 1 plus e raised to power pi over 2 n minus 1 and ex cos of t as this, and n could be 1, 2, 3 and so on. So in this way you can find the iterated kernels. You have to keep putting the values of n, 3, 4, 5 and so on unless and until you get some pattern and you are able to figure out how you can write the general iterated kernel. I hope you are clear with this. In the next video we're going to do this example that we have to solve the integral equation by the method of successive approximation.